Howdy everybody in YouTube land. I'm finally starting to get over the hump of this COVID thing. Back from the VCF Midwest show. Oh man, that was crazy. So, anyways, what we have in front of us today is a Magnavox little, I don't know, 12, 13-inch TV. Now, this is not mine. This is a friend of mine's, and it was used in the exhibit. Unfortunately, it quit working. Now, when we were at the show, we had a ton of power problems. I mean, we were running anywhere from 85 to 95 volts, depending on what time of the day it was and when. So some of our stuff didn't even work. So it's entirely possible that when I plug this thing in, it's going to work just fine. That would be hilarious because I drove it all the way down here from up there just to find out that it actually works fine. But you know what? Let's just figure that out right now. It's drawing power. Nope. Alright, it is indeed broken, so we definitely have a problem with this set. So hey, we get to have a repair video out of this. So let's figure out what this thing actually is. I like these little Magnavox sets. So yeah, it died on scene. It probably died because of the power issues. Then again, it could very well be coincidental. It could be, you know, something like that. Just age-related failures. Now, Magnavox is kind of known for capacitor issues because I actually have a Magnavox set in my bedroom that I've had since basically new. And that one had a cap failure in 2007 and I had to replace it. And it's been going ever since. But now this one is an older model than mine, because mine is a newer design language. See, this one was made in, 91, so mine was made in 94, so this is the older model. It's old enough to where chances are we're going to have probably a capacitor problem. The fact that it's drawing current when I plug it in means the main line fuse is not blown. So that's a good thing, because we don't want the main line fuse being blown, because then that means we've got flyback problems or voltage regulator transistor problems or something like that. So I don't know this design. I don't know if I recall ever working on one of these. And I've worked on a lot of TV sets, but I don't recall ever working on one of those. So hopefully it's something simple like a capacitor that's bad in a standby circuit, because it uses a microcontroller based technology, right? So that means we need 5-volt standby power. So it's probably a 12-volt standby circuit or 9-volt standby circuit, and then there's a 5-volt regulator and some capacitors, rectifier, you know, all the typical normal TV stuff that sets of this era have, right? So I'm going to take a wild guess that there's a problem in the standby circuit, so the microcontroller is not getting power anymore to turn on the set. Or we have the microcontroller is trying to turn the set on, but the relay is not engaging because we're missing 12 volts. Or the transistor that drives the relay is bad, or something like that. There's a lot of possibilities, but yeah. So I've not had this set apart yet, so we're gonna have to figure out how to figure this guy out. Changwa. Okay, so 1991 date code on the flyback transformer. That looks very suspiciously Phillips-like. Man, there's some tags inside here. This thing's high hours. For a little 13-inch set, that's surprisingly to me, because, I mean, TVs like this would have been used in like a kid's bedroom or the kitchen or something like that, I would suppose. Set that out of the way for now. It'll probably take me a good month to get over the leftovers of COVID. But luckily the fever's gone and all of that stuff, so. Alright. Okay. Ooh. Creaky. So, didn't realize Chungwa made these tubes, so. Yeah, there we go. There's some capacitors in here. I don't know what standby circuitry we have, but yeah, that transformer looks very, very Philips-like. So let me move this up and out of the way so it doesn't fall over. Dusty. Alright. Going in this with no service manual, no schematic. I'm sure I could find one, but I'm just going to go based on intuition. So what we need to do is we need to find the standby regulator, which is probably up here. So this is a hot chassis. It doesn't use a transformer. Nope. So it probably uses a linear voltage regulator. And we have some burnt up resistors. R432 does not look good. No. Ooh, this thing's got a lot of hours on it. Okay, we're gonna have to pull this chassis entirely, and we're gonna have to start testing components. I don't know if this one's gonna be a simple, straightforward capacitor issue. I don't think so. I could be wrong, because I'm taking a guess at this point, but I don't know. The degaussing coil fired up because we heard that, so we know the main line fuse is good. These little sets are nice sets though, so it's getting harder and harder to find people that actually know how to work on CRTs. Now, granted, luckily, people are getting into it because of retro gaming or whatever the reasons are anymore. And it's created a movement where people want to actually learn how to work on this stuff and are actively learning how to work on it. There's a guy I just learned of recently, Andy, out in California, who's around my age actually, maybe a little bit younger, who learned how to work on CRTs over the years and does it for vintage gaming reasons, professional BDM, stuff like that. And he's created a CRT database that lists all known trouble faults and stuff like that. So that is handy. If more people could do that, that would be great, because we've got to keep these things preserved. Because the thing is, the old school technicians are retiring out, they're dying off, and there's nobody really to replace them except us. I mean, we are it. We are the generation. We are the generation to keep this stuff going forward, and even Gen Z at this point. So we've got to keep this stuff alive at this point. That's the only way to keep going forward with it, right? So enough of the political speech. Yeah, I gotta get this out, which means I need both hands. This thing's nasty. Starting to slide the chassis out now, and I got all the plugs loose. But last thing we got to deal with now is this anode cap. Now, I love this tool because not only is it good for testing, you know, your high voltages, but you can actually use it as a discharge bleed off. So I just want to keep that up inside the anode cap, like so. Get it up under there and make sure it's discharged. I mean, yeah, you could just use a jumper wire or whatever, but that tool is my new go-to, because it will just bleed off the charge right into there. And there is no charge, which I didn't expect there would be, because it's been a week now since it died at the show. So, yes. That's what we got. Man, that's nasty. Okay. Now, the other thing I noticed is the convergence centering rings here it's like it's been knocked out of. That doesn't seem right. You can see the dust ring where it was down further a little bit. So, I don't know what happened there, but I'm not going to mess with it. But if the convergence is way out, yeah, that's why. Okay, so now we can actually slide this board out of the set. Really? I know this was just plugged in, so be careful where you grab these, because the chassis itself could still be charged. Alright, so now the board is out. Microcontroller must be under this guy here. Oh, STR regulator, very common for the time period. We've got some IC there, I don't know. There's not many capacitors on this thing at all. Not really, and they're all of good quality too. So I'm not expecting that to be my issue, although you never know. Look at these dropping resistors. Oh, it's built to a price, that's for sure. Yep, there's the 5-volt standby. So I need to chase that circuit and figure out where it's actually coming from, because we got a problem with that standby voltage. Yeah, so horizontal, or there's the vertical output IC there. That appears to be the horizontal output. And I'm not sure what you are, or why you're there yet. And there's the main B+ voltage regulator. So there's probably a 100 UF, 100 volt cap. Yeah, there it is, right there. That's a 100 UF, 200 volt cap. This is what goes bad on the newer models. Like the one I have, these go bad often. And it's because they're not respect for the temperatures they run at, and that's why they failed. Because I replaced it in 07 with a much higher quality cap, and it's still going. So yeah, it lasts longer than it did from the time it was new. Okay, enough rambling. Let's see. Alright, now, if I can get service data on this thing, that would be a miracle. But I don't think I'm going to be able to do that. So step one is to find some rough-looking solder joints, which, yeah, anything's possible in that domain, but I don't see anything. You could see where all the voltages are running, because what voltage does, it's like static electricity, it draws in dust. So you can see where current was flowing continuously, so I can trace out what had voltage, like this transistor here, the dusty trace, and what doesn't, like this one here. So this one was carrying a higher voltage. This was carrying a higher, they're all carrying high voltages, so I can test that entire path to make sure that we're still good there. So we have a standby voltage. And I think our problem is the standby voltage, but I have to find that actual supply, which I don't know where that is at this point. So I got to do some checks, but first off, I need to get rid of this so I can get this where I can get my meter set up. Now, for troubleshooting these kind of TVs, you really don't need to understand the engineering and theory of operation of the whole thing down to the mathematics level. That's not really important. But you do need some basic understanding of the design on how these types of CRT sets work in a fundamental degree. So, and from this era, they're all about the same. So when it comes to the cheap sets like this, we've got the voltage regulator that provides a stable B+ to the horizontal scan circuitry of the line output transformer. And all of the other voltages that the sets need to operate are derived from the flyback transformer. That's how these things operate. So the microcontroller, it appears that the microcontroller is a big jungle chip that's generating the horizontal vertical drive voltages and all of that stuff. So that means, in theory, as soon as I hit this power button, I should get a drive signal to the horizontal output transistor, which kicks everything on. And then there's feedback loop that goes into a shutdown X-ray protection. So if something goes wrong, the microcontroller will shut it all down, right? Now, in order to troubleshoot this thing, my current approach to this, without the service documentation, my current approach to troubleshoot this was to do quick dry checks to look for shorts and stuff like that. Open resistors on here, because this is part of the voltage regulation. I didn't see any of that. I didn't see any broken solder joints. So the next step logical step to this is to remove the horizontal output transistor and plug this thing in and do some quick voltage checks. Because in theory, when the microcontroller is got standby, the minute I press the power button, I should get horizontal drive to that transistor, even if momentarily. But with the transistor removed, it's not going to kill me with everything disconnected. So that's the approach that I'm going to take to troubleshoot this board. I'm going to remove the horizontal output transistor. I'm going to power this board up, and we're going to do some quick dry voltage checks and figure out where we're losing it. But the good thing about this board is there are several test points. Like you've got a 129 volt test point here. You got a 5 volt test point over here. There's another 9 volt test point over there. There's another 5 volt test point over here. 155 volt. There's tons and tons of test points, so you'll know if things are working properly or not. There's a 13 volt test point there too. What you won't know is which ones are scan derived and which ones are B+ derived. We're not going to have that information unless we have the service documentation. I could go looking for the service documentation, but I want to take the approach that there is none available here, because this should be a simple fault as long as the microcontroller did not fail. Now, if the microcontroller is getting standby voltage, then yes, we have a problem with the microcontroller, and that's not a good thing. So let's hope that it is not that. Alright, so now that the horizontal output transistor is been removed and out of the way, we're safe to attempt to power this thing up. So let's plug power in. Alright, power is on. So let's find a ground point for my probe, which this is all should be the same ground potential because this is a hot chassis. Otherwise you'd have a cold and hot side ground. See, it's the same ground. Okay, immediately, I need the other hand. Immediately, I'm going to go down to this 5 volt test point and check it. Well, we're down to 1.1 volts, so that's not going to work. So there's our problem. Alright, so let's check some other ones. Let's see, there's test point 12, 9 volt. Yeah, no. Let's see, 129 volt TP4. Nope, that's not working either. Test point, 13 volts. No. Let's see, test point, 155 volt. We got that at least. Well, it's a little high, but that could be line voltage reasons, right? So, we have it here, but we don't have it anywhere else. Zener diode, 2.9 volts. So, but I'm noticing it's slowly climbing. So, yeah, see, it's climbing. It's creeping up. So, which capacitor is it? Let's look at this R432, which I thought was a problem. 16 volts on one side. Now, it's the same. Okay, so, let's see, on this side we got 166, that side we got, same thing, so that's not it. Okay, so, let's see what we got here. I don't know if we have any other test points. Yeah, this is 5 volt IF. Yeah, it probably won't work unless it's actually told to come on. But our 5 volt standby is nearly non-existent, so. Alright, that's our issue. We've got low standby voltage. Now, why do we have low standby voltage? Well, there's many causes for that. We could have a bad shorted Zener diode transistor, but the fact that we've got good 155, but we're kind of low everywhere else, kind of makes me think we've got something that's not passing voltage across. But so what I'm going to do next is, here's how you roll out capacitors instead of chasing voltages. Although, look at this, R407. Look at that. She looks toasty. You know what? Let's take. I wonder if the STR failed, because I think these voltage regulators run all the time. Let's look on one side of R407. 15.8 volts. Look on the other side of R407. 2.1 volts. That's awful close to my 5 volts over here. So, that's an issue. Let's check this voltage now, make sure it's falling. It is. There's something definitely consuming current, so I'm going to let that fall. Because this is when I say, and most people say in videos, be careful, capacitors can retain a charge. Well, this is that charge that they're talking about. I'm watching it drain off right now. So that resistor looks a little toasty. This 407, I'm kind of suspecting something's up with that, but that could be heat tolerance too, so it's hard to say. Now this STR could be bad. I've seen them go bad. I've had to change a few in my day, in my early days of working on TVs back when it was, you know, the nepotism era. But alright, that's safe enough to not matter. Yeah, it's kind of crunchy in the middle there, so I want to measure that out real quick. Let's see, assuming I can, I'm going to need service documentation now because the resistance is, or the resistor color code is so fried that, yeah, that's not right. I'm going to tell you that right now. That's open. That is open. Why is it open? We're going to need service documentation, so we need to locate that. Alright, so because I don't know what R407 is, and we know that it reads open, I didn't have a choice but to go looking for service data. In a situation where you can't find service data, you'd have to find another chassis, or possibly do a little bit of circuit reverse engineering and guesswork, which can be dangerous. And it requires experience to do that. But luckily, there's no service data out there except for SAMs. So unfortunately, I had to go and had to buy the SAMs. But at least I have it now. And this covers this chassis and plus a bunch of other chassis as well. And now we can kind of see what's going on here. So this is the resistor that went open circuit. I measured this transistor here, which is over here, and it's fine. Q403, which is this, is also fine. And the 5 volt standby regulator, would you look at that, 407 feeds that off as well. That's why it's low. Now, I checked this circuit here, and it's also fine. I'm not entirely certain what's going on. Xenon diode and all that's fine, but what I did notice is C415, which is the filter capacitor for the 5 volt supply, is way down here, next to these nice heat baking capacitors, right? Or heat baking resistors, I should say. And that's the thing when I talk about experience. Like, if you don't have service data, you always want to look for things such as caps being right next to things that are going to get super hot, like a heat form, such as this guy. There's a cap here, and there's a cap here. These two are vulnerable to drying out due to the heat produced right there. Same thing over here. Look at all these resistors in parallel. Look how big they are. This is designed to put off some heat. Well, this cap is right next to it. And it's been 30 years since this thing was made. So that cap could be dried out. I am going to pull it and replace it. But I also need to pull this resistor too. So is the next resistor going to fry? What caused the resistor to fry in the first place? Did this cap go bad and cause this resistor to fry? I don't know. But what I do know is I'm going to pull that and check it, and this is definitely bad. But it has nothing to do with the STR, at least when I first thought, because of how close the connections are here. No. It takes the output. It's part of a tap and it runs off down. So yes, this is why we have 1 volt here, is because this is open. So with that being open, there's a bunch of this stuff that's not going to work. So, since I don't have, this isn't blown, this isn't bad. The problem could be here on the regulator, or it could be down here, although it's kind of going off. Actually, no. From what I could tell here, it's one of those weird kickstart style power supplies. This is the flyback transformer. And that's what I mean by the flyback. The flyback generates a bunch of different supplies, including this one. Now, I can check these two to make sure they didn't go open. Because if this went bad, because when the scan circuitry kicks on and everything starts to run, this voltage replaces everything else. This is only enough. This is your kickstart resistor. Just like that 100 k ohm that went open in the WeatherStar 4000 at the show. This resistor is what trickles the voltage into the standby because this diode blocks it. This diode blocks it. So it only powers the standby. Right? So once the standby comes up, the microcontroller starts generating the horizontal drive, this voltage takes over, which runs everything else. Right? So that resistor should not burn open unless something went wrong with this circuit somewhere. So I need to check everything in this path here, and I need to check back here to make sure this is coming up. So I think something's amiss here, which fried that resistor. So we're going to fry another one if we don't track the actual problem down. So let's keep digging at it. Alright, so I pulled this 100 microfarad cap out, and it's under test right now, and it's only getting 76 microfarad at 1.8 ESR, or 1.18 I mean. So yeah, that's done. That cap would probably still work, but it's not, it's out of tolerance. So we're going to replace it. There's a 47 here in that same circuit, but what I don't know is why. Let's take a look and see. We've got 408 here. So 408, where are you? Oh, that's a different one, and it's 100. Yeah, it's fine. So we got 407 that died. 415's out of spec. 470 and Z470 and R412. It's a 9-volt source. So where's 412? R412 is where I think my concern there is I think that's all hidden under this shield because I can't find either of those three parts. R412. Oh, there's C411. Yeah, it's, yep, right there. It's just hidden right in there. So I can't get to that. There's Z410, which is also good. Yeah, I checked that. Yeah, I don't know. I guess we're just going to have to roll the dice and just put those two components back in it with new ones and see what we get. I'm sure all these capacitors could stand to be changed because of just how many hours they're on it and how old it is, but I just want to try to resurrect it and see if we can actually get this thing working, because that's the goal. Alright, so here we go. Got the resistor reinstalled, got a cap put in here. So it's either going to work or it's going to fry the resistor immediately. So here we go. Alright, no explosions yet. Let's put that in there. And let's check for 5 volts standby. And we have it. Power on. Bingo. Our source is there. We have the proper voltages. See, is our 9 volts is our 5 volt IF present? No, because it probably shut down. Oh, you know what? If there's no scan supply, it's not going to do anything. The TV is actually turning on and off because I can see the jump in the millivolts there. Yep. So that's working. And if I turn the TV on, see if I can do this single-handedly. without frying anything. TV is on. TV is off. Yep, it's working. Okay. Alright, I think we're good. What caused that resistor to burn out? It's hard to say. Like I said, we were having voltage problems at the show. So anything could have happened. Like I said, if you watched my previous video, or well, this TV video will probably come out. I don't know. I might release this video immediately after the VCF video. But if you watch my previous video, the 4000 had a resistor that died in it, the soft start resistor. Well, it seems kind of ironic. The same exact trickle soft start type setup did the same thing in this TV. So yeah, I went ahead and changed this cap anyways because it was out of tolerance. But they could all stand to be changed. I just don't want to put that amount of effort into this kind of TV. But yeah. So all right, get that out of the way, and then let's put it back together and see if it fires up. It should. All right, it's showtime. It's either going to work or it's not. There goes the degaussing circuit. Let's turn it on. It's running. I hear it. So do we have a picture? Yes, we do. How about that? Fixed. Alright, well that was a quick and simple repair. Yeah, so just that resistor, and I changed that capacitor, which that capacitor was likely just a preventative thing. It didn't cause this issue. I think the crappy power we had at the venue is what did this thing in. Likely because of a voltage spike or something like that, because we had to fix the 4000 power supply, and then I remember Jesse telling me that this thing quit on him as well. And, well, there you go. That's why. So, it's fixed. That was a quick and short little video. So, yeah. We can go ahead and put this thing back together. Alright, so here we go. Turn you back on. Turn you on. Alright. Actually, the convergence is really good on this set. Wow. We got good color. Yeah, color's pretty good. I mean, it's not the best, but it's not bad for what it is. I mean, this TV was cheap when new. Yeah, we're good. I'm just gonna leave it just like that. So yeah, it's fully functional. This is a quick, short little video. Found a bad resistor and a weak capacitor, which it would have probably worked fine with that cap left in it. It was probably the voltage issue we had at the show. But anyways, if this video taught you something, and I hope you learned something, don't forget to hit the like and subscribe and all of that fun stuff. And if you have a comment, please feel free to leave one. Until next time, guys, thank you for watching.